So thank you for coming to my talk. We are going to be talking about AT-ATs, and hopefully at the end of this talk, you will depart from here with the knowledge to go forth and either use one of the AT-ATs that I have benevolently provided on the internet for you, or go build your own. Or at least you'll know what the heck an AT-AT is. Well, let's see here. There we go. What's up?
It's an AT-AT.
Huh?
AT-AT.
Oh, an AT-AT. Oh. Am I not being canon? Oh. Bob Iger, everybody. We got Bob Iger in there. I'm just kidding. My name's Mark Tinderholt. Nice to meet you guys. I work for Microsoft, and I am an engineer, so I'm not going to sell you anything or anything like that. All of the stuff I'm about to tell you are my personal opinions. I'm not speaking on behalf of Microsoft in any way. I have to tell you this, okay? Otherwise, Sela is going to come schedule an unannounced meeting with me on Friday. So, I happen to just be really passionate about Terraform and automation, which has led me to become a HashiCorp ambassador. I don't do anything with like Terraform officially in my job other than use it. So I'm just like, how many of you guys know what Terraform is? Wow, that's a lot of hands. That's awesome. Okay. I was a little, I wasn't sure what was going to happen today, but yeah, that's great. So I don't have to cover that many bases, but I'm just like you guys. I'm a user of Terraform. I have some colleagues at Microsoft that actually are responsible for delivering, the Terraform providers that we offer, which we offer quite a number of them, which is quite exciting. So, so that's me. So what is the agenda for today? So on this journey to piloting our AT-AT or our AT-AT, I thought, I wanted to define the problem statement first before we hop in the pilot seat, so to speak, or the cockpit. And so we'll take a tour down that and set some historical context for like where this whole idea of an AT-AT is coming from, and what the problem is. And then, when we hope to fix it, we'll hop in that pilot seat, and I'll hopefully give a live demo. Hopefully no horses will be injured in that, and we'll finish. So, so cloud ops, the evolution of cloud ops. And this is kind of where we're going with the AT-AT. We started with click ops, then script ops, then Git ops, right? And when cloud first emerged, right? It was really exciting. Like you could actually go out to a self-service portal and go provision your own infrastructure, and it was very enabling. You didn't have to, file a ticket and wait 2 weeks for a VM to show up in vSphere or something like that. It was like, wow, this is crazy, right? But and we still do this to this day. Like a lot of people, like they bring their bread home doing click ops. Based on the hands that I saw in the audience, a lot of you guys are familiar with Terraform, and so, this whole concept of infrastructure as code emerged to eliminate that tendency for humans to be human and make human errors and stuff like that. And so after, with ClickOps, it's really nice because you only need like a very basic understanding of the service that you're trying to provision. And honestly, it's a great way to learn and discover how to use the different services that are available out there on the cloud. And then, after you get comfortable with that, it's like, oh, well, you know what, we can write this down. I can use the CLI, I can use PowerShell, and I can kind of like perform those same tasks, but in kind of an automated fashion. And we started writing scripts in Bash, PowerShell. It made life easier. It was a little bit more reusable. Like we didn't have to go to the portal every time. We could share that script and be like, yo, dude, here's a script. It does all the things you need it to do. However, the nature of the way that we scripted, was a little bit harder to maintain. They tended to get a little bit ratty, a little bit spaghetti code. And that's when, we kind of emerged into this infrastructure as code world where we use functional DSL languages in order to describe what we want our environments to be, rather than, this very procedural way of doing things. And that allowed us to wrap software development lifecycle around that, which is where Git flow and then CI/CD came into play, where we can plug those aspects of how we deliver application code around our infrastructure code. And so GitOps is kind of like the next generation, or that kind of the culmination of all of these different approaches into a process that we use to provision infrastructure and ultimately our applications. So with GitOps, we have this new world order. There's a lot of components to setting up kind of a GitOps process. At the foundation, of course, given the name, right? You're going to expect that there's going to be source code involved. There's going to be a Git repo. And within that Git repo, we're going to have code and we're going to have config. And we're going to combine code and config in order to release our software. And within that code and config, ideally, the code is going to be the same code that runs on whatever environment, but the config is going to allow us to customize what environment we're going to be, provisioning, and maybe change some of the runtime settings that the code uses when it's in that runtime environment. We also, like with GitOps, there's this element of pipelines, and in the pipelines that I'm going to share with you today, we're going to be using a tool called Terraform. And whatever tool you're using, at some level, it is maintaining state. Now that state might be abstracted from you, or stored in like a etcd or something like that, or stored in behind the control plane in AWS or in Azure. In Terraform, we store state in a Terraform state backend, because we can't rely on the systems that we're automating to maintain that state for us. So that's kind of part of like how a Terraform release motion looks like. So we have this aspect of these pipelines that connect to state in order to preserve the changes that they enact within the environment. And when those pipelines execute, they need some kind of identity. We're no longer running those bash scripts or PowerShell scripts on our little workstations with our own identity. We're kind of delegating that to some agent or runner that's going to be executing that out wherever, right? In GitHub or in Azure DevOps or wherever, or on a Jenkins, or whatever. So those pipelines need some identity to execute, so that they can get the permissions that they need to perform whatever actions that they want. And they need that access to the environments that they need to perform those actions in. Typically, you would set up these just like in the source code. You have your configuration organized based on the environments that you're deploying to. You're going to have state, that represents each of those environments. You're going to have identity that is isolated for those environments, so that you have a little bit of least privilege there. The blast radius from a security standpoint is minimized, so that the attack vector is smaller. If dev is somehow compromised, the rest of the whole operation isn't compromised as well. So we can kind of focus the access to that identity to just access what it needs to access, not the whole subscription or the whole AWS account or the whole organization or whatever. So there's some parallelism between these components. And at the core is these pipelines, and these pipelines need to bring all this stuff together, right? The pipelines need to know about what they're executing, in this case Terraform. They need to know what state they're targeting in order to save state to. They need to know what identity to use, and they need to be pointed in the right direction at the environment they're going to be provisioning to. So in this case, the right Azure subscription, on AWS, the right AWS account, or on Google, the right project that you want to provision into. So whatever cloud, like all of these concepts are the same. It's just like you use different terms. So there's this back-end concept of like where the back-end context, where we store state. There's the authentication context, who we are when we go execute, whatever commands we're going to go execute. What environment we're provisioning, so that we know that how to configure it, and then like what are we going to run, like what version of Terraform and all that sort of stuff. So with this, like with these things all coming together, we have potentially like a new hope for how we can, provision our software, provision our infrastructure, or we have new problems, right? We have to set up all of that stuff within source control. We have to protect our branches, because now if somebody goes and makes a change within source control, that is going to potentially make it all the way to production, right? And so one small change to source control in configuration, we could take down like half the country, something like that. We need to configure a Terraform backend. First of all, we have to set up a backend. We have to configure the pipelines to point at it. We have to set up all those service accounts for all those different environments, unless we're just gonna create one account to rule them all and give it God level access, but then that opens us to unnecessary security risk. And then we have to grant it permissions. And then we have to grab all that stuff and like compile it together into these pipelines, and then maintain that. And that is a lot of stuff to do, right? So although this new world order of GitOps is promising all these wonderful things, drift detection, automation, reduce toil and things like that, it actually is a little bit of a daunting task for us as developers, trying to release our software. So how can we make that easier, right? Do we just go back to ClickOps and just keep doing that we're doing? Go to GitHub and clickety-clack, set up our repo, manually configure our GitHub actions, go out to Entra or AWS and configure all those IAM identities and all the permissions. And then once all of that crap is all set up, then, and only then, we can have this wonderful automation. Why do we do this? This is ridiculous. There is another way. I say nay. We should reject that. We should not fall back onto our ClickOps heritage, and we should find a better way to automate the automation. So it's time to suit up now and enter what I've been calling the AT-AT. That is, automate the automation with Terraform. And so that idea is creating a special type of Terraform module which will essentially automate not the infrastructure that we provision to the cloud, Azure, AWS, whatever, okay? But all of that stuff, all of that crap that we have to clickety-clack set up across multiple control planes, across our source control provider, GitHub, across our identity and access management system, Entra, whatever, okay? And then also across our cloud platform, AWS, Azure, we have to set up backends, we have to set up all this stuff, right? So an AT-AT basically is a Terraform module that uses the power of Terraform to automate those aspects so that right out of the gate, you have a fully working release pipeline to deploy your a GitOps environment, to release your software so that you don't have to set all that crap up yourself. That's the idea. And then, yeah, automate, boom, 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 there we go. So this is so meta, right? We're using Terraform in a very different way than people typically think. Now, this is not a new idea, okay? People have been doing this, but it's not completely new, but it's very meta. And so when I think of it as like, the normie infrastructure as code is, you take Terraform and you provision some stuff into Azure. And what we're going to do today is the AT-AT way of doing Terraform, which is we're going to automate the Terraform We're gonna terraform the Terraform to automate our environment, right? Such that once we're done, we have a fully working infrastructure lifecycle management and application lifecycle management process in our chosen tool chain, GitHub or whatever, such that we can follow this GitOps process to release our code. That's what we're trying to achieve. So the GitHub AT-AT is an open source project that I develop, and it's a very opinionated instance of an AT-AT module. Like I mentioned, an AT-AT is just a type of Terraform module. The GitHub AT-AT is a specific instance of that automates Azure. It sets up the storage accounts for your backend and provisions all the RBAC that's necessary for the Terraform backend to happen. It talks to Entra, so it sets up the service account, like those app registrations, and it sets up the federated identity credentials so that GitHub can now talk to Entra. And then it also it drops a bunch of code out into GitHub, right? That's what the GitHub AT-AT is. And it's been designed in a modular way, ironically, a composable way, such that you can kind of choose your own level of involvement, so to speak. So what's in the box? Well, the GitHub AT-AT starts with this standalone starter app, just so you can see what the crap it does, right? And basically, this is intended to allow you to run Terraform apply one time, and it shoots everything up there. It'll create the Terraform backend state, it'll create all of the stuff, and it'll create a starter app, which basically is an empty canvas in Azure that you can just, like a resource group, that you can just start dropping stuff into. And that's the basic level. But if you're going to operate infrastructure as code at scale, you're going to probably want to provision that shared infrastructure, that dual backend, to manage Terraform state across multiple environments. And then you're going to start stamping out applications one after the other. Probably not yourself, but hopefully in a broader organization, each of your teams are going to stamp out their own environments in this manner. And then the kind of creme de la creme, the goal of what we're trying to achieve, because this thing is composable, is we want to take that starter app and expand it to implement highly opinionated ALM, ILM implementations. What does that mean? We'll get into that, but infrastructure lifecycle management, application lifecycle management. What tech stack are we deploying to? What specific patterns are we trying to facilitate in a repeatable fashion? And what I kind of refer to these as variations on the theme. So the starter app, as I mentioned, is just that simple resource group in Azure. Like we provision all of that GitOps environment, and at the end of the day, once you run that release pipeline, it provisions a resource group, an empty resource group. And then you can use the infrastructure lifecycle management process to go add whatever you want to that. Kubernetes, app service, whatever. But once you've identified a pattern that you want to follow within your organization, whether it's just a common application archetype, or whether you're trying to endeavor down the path of like a microservices architecture, you're probably going to tread the same ground over again, not tread new ground every single time. And so we start seeing entire stacks, right? In this case, like Azure Functions. Like Azure Functions has some core infrastructure, an app service plan, a bunch of other things. And then when we stamp out individual environments, we get a function app. So we can stamp out function apps after provisioning that core infrastructure. Kubernetes kind of follows the same path. Like we need some core infrastructure, that AKS cluster, and then we stamp out applications that will all be running on that same shared infrastructure. And then there's the options are endless in terms of how you want to configure, the GitHub AT-AT or the AT-AT in general to implement whatever your infrastructure lifecycle management or application lifecycle management processes that you want to implement. The one that I'm going to be talking about today is the first one that I've implemented, which is the Azure Functions one. And so with Azure Functions, basically the GitHub AT-AT stamps out the shared infrastructure, and then it allows us to stamp out individual services on top of that. It's intended to be like facilitate implementing rapidly microservices architecture using Azure Functions. But each of these environments that we're provisioning, we have this core environment with some shared resources that are going to be used across all of these applications or all these services. That's going to be our app service plan, which is going to be kind of the shared environment where all these function apps are hosted. Could be where we set up a private network that all these things are attached to. We've got an observability stack. We have an event messaging stack using Event Grid. We have a secrets management environment using Key Vault that's shared across these environments. And then when we start stamping out these environments, it's going to be there's an application-specific environment that we provision that we actually deployed application code to. And that's going to allow each service to have its own autonomy in terms of the unique characteristics of how we develop that. Like what database types that is this service going to be using? Is it going to be using Cosmos or Postgres or storage? But then it also has hooks into that core shared infrastructure, such as that hosting environment, that networking environment, the observability environment, right? Where we tie all these things together, and through this app module, we can stamp out many of these things in order to achieve what we're trying to achieve, which is to lay down that core infrastructure, but then in a repeatable fashion, stamp out new projects following that same template. So now, I think we're ready for a live demo. So if you bear with me, I'm going to try and get out of this without too many scars, but we'll see how I do, okay? So let's pop over here, okay? So I'm just, oh, you guys can't see that. What the heck? Oh my gosh. I have to move this over there. Yeah. I apologize. I need to be able to see what I'm sharing with you. Mirror built-in display. How's that? Can you guys see that now? Wunderbar. Okay. So let's go out here. So here I am in the Azure portal. This is my list of resource groups. This is my Entra environment, and this is my GitHub environment. Okay. So let me drop into the GitHub AT-AT source code. So this is the example module for the GitHub AT-AT. You can go pull this repo and you can do exactly what I'm doing from your own laptop. You just need to be connected to GitHub and connected to Azure and have all the permissions that you need to be able to do all this stuff. But basically, this module right here, the functions core module, is going to be stamping out that shared infrastructure. And I've already done this to save some time, okay? The live demo, I'm gonna be provisioning a new service so you can see the infrastructure be laid out that's gonna attach to this core environment, and then the application code get deployed as well. But this core environment, I'm not gonna deploy it. I've already done that. But this module right here is how you deploy that shared, that core infrastructure. And so with the core infrastructure, we're defining n number of environments where we want this core infrastructure to live. So We can have a dev environment, a test environment, a prod environment, whatever type environment you want. You define what subscription you want it to be targeted to. Like right here, I've basically delineated between a non-prod and a prod subscription. So I have kind of this bicameral setup. And to implement my GitOps, I'm assigning each of those environments what branch, what long-lived branch you're going to live on, right? So my dev environment is going to live on the develop branch of this repo. And my test environment is going to live on the release branch. And the main branch, my production environment, is going to be on the main branch, which essentially means that whenever I submit a pull request on one of these branches and merge, my GitOps process is going to facilitate that infrastructure deployment, that infrastructure provisioning, and the deployment of my application code to that particular environment. So whatever the latest and well-tested infrastructure code and application code is going to be deployed to that target environment. So this is like the key configuration of the GitHub AT-AT, is to define your GitOps configuration. The rest is like what repo I want to provision and all that stuff. And after you provision it, it's going to create, this is the one that I did the other day, it's going to provision this GitHub repo with the source code for that core environment, right? Which in this case, the functions application is configured to be an active setup for Azure Functions. So if you want to provision an active very highly scalable environment, you can go do that. And this, so the GitHub AT-AT drops this source code repo with the Terraform code in it. It drops the GitHub Actions YAML files that are in this repo, and everything's all set up. So basically, all of these GitHub Actions are now available to me and facilitate that GitOps process. And you can see here, it executes and it runs Terraform apply and it provisions the environment. So if I go look at my CM2 core prod environment, this is the stuff that it sets up for me. So with the core environment established, I'm going to go and provision an individual application. So for my individual application, much the same, I'm going to be targeting a specific core environment that's aligned with the application lifecycle, dev, test, prod. I'm going to probably be configuring other things like who can review this application source code and things like that, and basically pointing it at the environment that I want it to deploy to. So I'm in this app here. I've set up this file right here. This is a parameters file. It's going to configure a new service. I'm just calling it CodeMash 2 Service 2. So we're going to target the CodeMash 2 core environment, and we're going to create an entirely new GitHub repo. So let's say Terraform workspace list. Just want to make sure I'm in the right workspace. So I'm in CodeMash 2 Service 2. And then I'm going to run Terraform apply. I'm going to say var file equals debug. I don't make it easy on myself with these weird var file names, TFVars. Okay. And so just by running Terraform apply with this var file, I'm setting the context for the GitHub AT-AT to say, here's what I want you to go do. I want you to target this core environment, and I want to add an entire new GitOps environment to this for an entirely new application that's going to be that I'm going to manage long term. So you can see the GitHub AT-AT, when I run Terraform, it comes back with a Terraform plan, which if you guys have used Terraform before, you know what that is. And we have a bunch of stuff that's going to be provisioning. Now, none of this stuff is AWS stuff or Azure stuff. Notice it's GitHub stuff, right? So we're going to be provisioning a source code repo, and all the files and things like that. So let me run this, and we'll get it off to the races. So what this Terraform apply is going to be doing is it's going to be talking to GitHub. It's going to be standing up a new repository on GitHub with, and it's already there, right? And it's going to be setting up the infrastructure code that's going to be managing this new Azure Functions environment, the Terraform code, that infrastructure code. It's also going to be setting up C# code that is going to be compiled as part of a CI/CD process and eventually deployed to the environment that this GitHub repo is going to be provisioning. And then, of course, it also sets up all of those GitHub actions as basically YAML files within this repo in order to make that happen. Let me, am I playing Terraform Pinata? No. So, what it's also doing, which you can't see, besides failing. All right, I got one sledgehammer in one window. Okay, I can take one. We'll try this again. Hopefully I can get out of this with 2, or less than 2. So occasionally there's transient failures when you run a Terraform apply. In this case, I think the GitHub provider, there's like some race condition with like a GitHub branch that I haven't quite ironed out yet, but it's essentially like, you know, that kids game like at birthday parties where you play piñata, and the goal is to get all the candy out. You get a stick, you whack the piñata one time, you don't quite get the candy out, you just whack it one more time and all the candy comes out. That's basically what I just did. So while that's going, sorry. Okay, so while that's doing, another thing that you're not seeing is, in addition to dropping this repo on GitHub, we're also dropping stuff into Entra ID. So we're setting up, let me see if I can find it, CM2 service 2, yeah. So this is the completely new service that I'm deploying, service 2, very creative, and I apologize. But service 2 is going to have 3 different environments. Each environment has its own identity that allows me to provision to it. I've got an identity in Entra for dev, test, and prod. And this guy right here, CM2 service 2. This identity allows me to give very specific permissions just to that identity to only access that environment, right? Which means I'm a little bit safer. Like, I'm not just like handing out God mode to like candy, right? Now, in each of these Entra IDs, identities, I'm also doing a lot of the legwork of, where is it? I forget. I don't click ops very much. Oh yeah, it's here. Yeah. So I'm also setting up this federated identity credential, and so this is something that the GitHub AT-AT is provisioning for you. So it knows about the GitHub source code repository, and it's plugging in all this crap for you. Remember all that crap that I talked about? You gotta set all this stuff up with ClickOps. Like, human beings do this today, and it's very human error prone. Just as human error prone as provisioning EC2 instances used to be, right? So why the hell do we do this, right? So the GitHub AT-AT sets all this crap up for you, it configures it, and so this allows our GitHub actions in that GitHub repo to go talk to Azure and do and only access that part of Azure that we wanted to access. So let's see how we're doing. Let's make sure I don't have any more broken windows. So it's still running. Let's go check in like as it's going. So we have some more stuff in our GitHub repo. We have some source code. So I've got a source folder and I've got some Terraform code, and this is the infrastructure code, right? That's going to provision this application's environment using the shared infrastructure that I've already, this is a cooking show, right? I pre-baked that before I got on the show, right? And so we're leveraging that shared environment, and we're provisioning basically, we're referencing that shared environment here. We're stamping out active environment for this Azure function. So if I want to do, 2 regions, n regions, like I can do that. I also have .NET code here. So this is my service. It's not a very exciting service, but we do have some things in here. So the GitHub AT-AT Azure function has out of the box health probe. We'll look at that later. It's going to light up and we'll see it report itself as healthy. But it also has its own internal messaging system using Event Grid. So this internal service can basically do asynchronous fan out like operations internally. It also has simple HTTP trigger so that you can implement message-based communication. So this Azure function template is very simple. I'm just starting to expand it, but it ties into the observability stack that's in our core environment. So right out of the gate, we have application insights, we have Azure Monitor configured, and so we have that nice telemetry. We can see what's going on within the service. We have it connected to an Azure storage account, so we can store data like the microservices data to Azure Blob or Azure Table Storage. And we're talking to Event Grid for internal microservice functionality, but we also talk to a shared Event Grid topic that's in the core infrastructure to allow us to do cross-service communication. So basically like the party line, right? Like, we have our own little private like telephone conversation, but we also have the party line that we can go if we want other services to be aware of events that are happening within our service. We can publish there. And what else? Oh yeah, we have all these GitHub actions that implement our GitOps workflow, and it's done all the hard work to set up individual environment triggers for the individual branches that we configured within the GitHub AT-AT. Remember I mentioned the develop and the release and the main branch? All of those have specific triggers such that when our developers or ourselves are submitting pull requests on particular long-lived branches, that's going to trigger an application, an infrastructure provision and an application deployment to that target environment. So all of that stuff is set up for us. And we can go see those GitHub actions here. Ooh, we might be done. So, I keep doing that, I apologize. Yeah, we're done. So we provisioned 99, I think it was 113 resources. Imagine that, 113 things that humans used to have to go across multiple control planes. You'd have to go into GitHub and you'd have to go into Entra, you have to go into Azure, like it's insane. And Terraform with this AT-AT module did it beautifully across, one broken window, I apologize. But beautifully across all those environments, we configured 113 things. That's pretty nice. So let's go look at what's happening here. So we have I just gave you a tour of this source code repository that we provisioned for Service 2. And we saw that, we saw the infrastructure code, we saw the application code, and we saw the pipeline code. While that's running, I also want to show you the other stuff that we've configured, right? So we've set up dev, test, prod in GitHub, right? And each of these environments have a bunch of stuff, right? That's specific. Again, this goes back to that pipeline as kind of the crossroads of our GitOps environment. Like, it has to be pointed in the right direction. It has to know what identity to use, what backend state to use, what environment it's going to be targeting, right? And so that's what these environment parameters are doing, and the GitHub Actions YAML are picking up on that. And so this pipeline right here, let's see, wow, we are well on our way here. So this pipeline triggers whenever we do a pull request and merge onto the main branch, and it's going to be provisioning our production environment. And so when we run the build, it's compiling that .NET code and running unit tests and stuff like that for that .NET code. When we run the Terraform plan, It's evaluating what the infrastructure as code is, and it's going to say, what's currently out in the environment? What do I need to go provision? It's creating a resource group. It's creating an Azure, a function app. It's creating application insights hooks so that we can have web tests to monitor the health probes of the actual function. It's doing a lot of things. And then after Terraform plan is executed, this particular pipeline is going to go ahead and run Terraform apply, which is essentially a Captain Picard moment. I know my theme's kind of Star Wars, but he's like, make it so, okay? And so Terraform's going to make it so, and that's what Terraform apply does, and it provisions our environment completely. And then once that's done, we are going. I'm sorry, I keep bouncing around here. We deploy our application code, and that's we have that packaged artifact of that Azure function, in this case C# code, compiled, packaged into a zip, and we deploy that to this Azure function that we just provisioned. And so if we go out to our environment, this is that core environment. I'm going to smash refresh. Let me do CM2, narrow it down a bit. So we have our core environment here for CodeMash 2, and we have Service 1, which I provisioned the other day, and we have Service 2, which I just provisioned right now. And again, the Azure Functions implementation in the GitHub AT-AT is designed to enable you to build active-active, like microservice environments. In this case, I'm just doing one environment. So here's that new Azure function with all the crap that it needs. It has an Azure storage account, it has its own event grid topic, it has its own key vault, it has its own user assigned managed identity, which grants it access to all the things that it needs. And we're now in kind of vanilla, normie infrastructure as code at this point, right? Which is what we want. That's another beautiful thing about this approach. There's no strings attached, right? You can forget about my GitHub, my AT-AT pilot helmet. Like you can go on and chase butterflies, and like the whole AT-AT thing can recede into your memory banks and fall off to that, the lapse of time. What you're left with is a fully operational infrastructure lifecycle management process, application lifecycle management process that you can tweak and configure and evolve over time to meet whatever your requirements are for your specific use case. And there's no overbearing nanny framework that has tentacles that stays connected with you long term. And as evidenced by this, basically what you see is what you get. You have all the infrastructure code, you have all the application code, you have all the YAML that's making this so, and it's happening right before your eyes. And so now this deployment just happened. Let's go see if this thing's alive and well. I'm going to pop into my core environment, and I'm going to go look at, before I do that, let me pop into the function, make sure, you got to check and make sure the function actually showed up. Oh, look at that there, okay. Usually a green checkbox is a good thing. It's an indicator of a good thing, but it's not conclusive. But so these are all the functions that I provision within that function app. I have published, these are kind of boilerplate samples, right, to show you that stuff works. But I have an external publisher function, which essentially publishes an event to that the party line, the event grid topic that broadcasts across all services. This is my external subscriber, such that if other services are publishing events to that shared topic, I'm going to get it and I can take action if I so choose. Then I have my internal publisher and my internal subscriber, and then I have a health check. Basically, I've got a readiness probe and a liveness probe, and these are again boilerplate. You can go and expand. You'd probably want to expand the readiness probe to go check all the things that this function happens to do. The liveness probe is just is it actually running? I'm kind of borrowing from a Kubernetes concept of liveness and readiness, but These probes are used in my core environment within Application Insights. So if I go out into Application Insights, I click on Availability, and we have a little blip. Yeah. That's the last 24 hours. So both services are out here. And this blip is when I've initially provisioned service 2, it's not healthy, but it came online very shortly thereafter. And so if I scroll down, it's not online yet. We have the little warning indicator because all of its health metrics, like it hasn't been healthy through this whole time period. So, but if you look at the graph here, service 2 was unhealthy. I don't know what time that is, 8:38. And now it's reporting healthy, right? So that, the ILM that we provisioned, we set up all of those health probes within Azure to basically say, let me know when this service is down, let me know when the service is up. And once the application code was deployed and like the function actually started running, then it started reporting healthy. So that's my demo. Let me pop back over here. So I got out of that with one broken window, I feel like. Not too bad. So this AT-AT, again, I'm going back to the beginning. An AT-AT doesn't have to talk to Azure. It doesn't have to talk to GitHub. It's a pattern. It's an approach to using Terraform in a different way. Instead of just using Terraform to provision stuff to AWS or Azure, which I highly recommend, but to eliminate the toil that you have in trying to implement your own GitOps operation. So I've implemented 2 AT-ATs thus far, one for GitHub and one for Azure DevOps. And I've just started down the path of expanding the GitHub AT-AT to enhance like more of these variations on the theme as I call them. But Terraform, one of the superpowers of Terraform is it's not a very exclusive thing. Like it talks to everybody. There's a provider for everybody. So if you want to use a different source control provider, if you want to use a different pipeline provider, if you want to use a different cloud, a different identity provider, those building blocks are available to you to go forth and make your own AT-AT for your own tool chain, for your own GitOps environment, however that manifests within your organization. I work for Microsoft, so I'm obviously going to be a little bit more biased and focused on GitHub and Azure DevOps and Azure and Entra, but these principles can be applied to anything out there. And I highly encourage you to go pursue that. So the key takeaways. Terraform does more than provision EC2 instances, okay? As a HashiCorp ambassador, I meet a lot of people that use Terraform, and I often jest that if you get a gaggle of Terraform developers and throw a rock at them, don't do this. You're gonna hit an AWS guy, right? It's highly saturated in the AWS space, and that's okay. But the important thing is Terraform does a lot more than AWS. And it does a lot more than just your traditional infrastructure, which, as you saw today. So it's a very flexible tool that can be applied to solving many different problems. And I highly recommend, don't look at it from that very, myopic lens of Terraform is just that thing that you use for EC2 instances. And the second thing is there's a tremendous amount of ClickOps out there besides just provisioning EC2 instances, as I tried to articulate. So whatever control plane you have friction and toil, and you see yourself repeating the same problems, thank you, I'm wrapping up. You see yourself repeating those same problems. Automation through infrastructure as code, through this configuration as code via Terraform, can help you eliminate that friction and toil from whatever you're doing. And then lastly, this is for all those Terraform, all those hands that went up where you're already familiar with Terraform. Adding composability to your Terraform modules can enhance the flexibility of the use cases that you're trying to target. So think about applying software design processes to the Terraform modules that you create. Don't go too crazy. If you want to talk about that with me afterward, we're not trying to enforce like a dry kind of mentality, that we get from traditional software development. But you can strike a balance between going all like too many abstractions and like being too procedural. But employing some level of composition into your Terraform modules can allow you to take something like that starter app in the GitHub AT-AT and expand it to something way more sophisticated, way more opinionated, right? Like with the Azure functions, that was 100% opinionated, right? That's like Mark Tinderholt style Azure functions right there on display. But I didn't have to start from scratch. I didn't copy pasta. Like I had a foundation, I could build from that. So that's an important design aspect when you approach Terraform module development. Those are my key takeaways. Thank you so much for your time and your attention and humoring me with my little AT-AT pilot helmet. Unfortunately, I did not leave an AT-AT pilot helmet under every chair in this auditorium, so you'll have to buy your own. But the source code is for free. So go out, look me up on social media, look me up on GitHub. You can go download my GitHub AT-AT, start using it yourself. You just have to log into the Azure CLI and the GitHub CLI, and you are off to the races. That's it. Any questions? Yes, sir.
So for your pull request process, is that where you review your plan?
Yeah.
I noticed in your deployment you have this go straight from plan to apply.
Right. So, yeah, totally. So that's a very insightful question. So in the demo, unfortunately, when the GitHub AT-AT runs for the very first time, it's merging onto main. So the GitHub provider that the AT-AT uses, the Terraform provider for GitHub that the AT-AT uses, it's actually dropping files into main. And as a result, there is a happy or not so happy like race condition where the YAML file that triggers off of a merge into main will actually trigger when that happens. So what you saw was a little bit of a snafu in the demo, but you're absolutely right. Under normal conditions, this pipeline only gets invoked after a merge onto main. So the other pull request processes are based on like a pull request in the branch. So you have a PR, where is it? So yeah, you get I think this is, you can't see it. Let me go into the code here. So if you look in the workflows here, there's a YAML file basically that triggers on pull request in each of those branches. Those like when we configured our Git flow, develop, release, main, there's a pull request branch that triggers on the pull request, and it does a plan, right? So you review the plan, and then once you're comfortable with what the plan is going to go do, then you go and like merge that pull request, and then the main like pipeline, which you saw, actually does the apply. However, there's also a capability which I don't know if you saw, I kind of glossed over this, but if you add reviewers, which I left it blank, I left the reviewers empty, you can make it so that the apply requires a reviewer approval, such that it will stop, and then once those approvers are like, yeah, I've reviewed the plan, we're good to go, like do it, right? Then, yeah, but good question, yeah. Another thing you didn't see was the .NET code. Because the Azure Functions is opinionated implementation of .NET, there's a .NET test, and there's a .NET integration test. So I use the XUnit filter attribute to only execute unit tests or only execute integration tests. And what I hope to achieve eventually is to provide a way to create a just-in-time environment so that you can run full regression testing with a brand spanking new environment out in Azure that Terraform will provision, deploy your code, run an exhaustive system test, as it were, and then destroy the environment. And then it's like, okay, I feel very confident that these changes are ready for production. But I haven't quite implemented that yet. Any other questions? Yes, sir.
What's the GitHub repo again?
The GitHub repo. So if you go to, so this is me, Mark TI. It's actually in a repo called Azure Terraformer. Where is that? There it is. And so this is my own little thing.
Okay, so you still have a presentation on that.
Oh, do I? I'm sorry. How do I?
Share screen.
I thought I did that. I thought I mirrored. Oh, yeah, there we go. You can see that, right? So this is the repo. It's at Azure. My organization is called Azure Terraformer. That's like my little side project. I have a YouTube channel, blah blah blah. I make funny videos, post them on the internet. But I also have a GitHub organization, and this is where I publish my Terraform modules. So you can go to registry.terraform. Where is it? Registry.terraform.io, and you can find my AT-AT module in the module registry, or you can go to my GitHub repo and clone it and have fun. But yeah, Azure Terra. Other questions?
Yeah. Excuse me, I don't know Terraform that well, but would your typical workflow, like say you added like a new Node.js project, would you edit your Terraform, or do you go into those YAML files that are in the repo?
Yeah.
What's that workflow?
So this is a question about the variations on the theme, right? So let's say we don't want to do C#. We're a Node shop, right? That's where the module composability comes into play. I have built, so the GitHub AT-AT is actually a mesh of Terraform modules. So you would just need to go to the GitHub AT-AT, replace the .NET module with your own implementation of Node.js, right? And the rest of the stuff would work. Okay. So there's a module that drops the .NET code, and then there's a module that drops the GitHub Actions for the .NET. So you'd have to pull those out, plug in your own, have a little Indiana Jones moment,
I see.
Yeah. Does that make sense?
Yeah, I think so.
Okay.
So,
Yes, sir.
going back on this question. So I see that there's other repos in your Azure Terraform. So those repos have the code that generate the pieces that AT-AT.
Yes, yeah, they do. And you can see them referenced within the AT-AT module themselves. So if you go look at this code right here, so this folder right here that's called, yeah, you can see that. So this is the one that does the function app. So in this code, I'm using this module called Terraform Azure Environment. And I think that provisions the Terraform infrastructure lifecycle management. So if you want to use Terraform to provision your infrastructure, that's the module you use. If you want to use Bicep, go roll your own. If you want to use Pull.me, go roll your own, right? Because the AT-AT is using Terraform to automate Terraform, I kind of presume most people are probably just going to use Terraform for their infrastructure lifecycle management anyway, but there's nothing stopping you from rocking bicep in here. But yeah, there's other modules here. This sets up, the GitHub credential, that's needed to talk to Azure. So if you want to go rock AWS, go set up your own GitHub credential for AWS. So this Azure FN function, I'm a math nerd, app is actually composed of several other modules that bring all of the other aspects of the GitHub AT-AT module library together. Yeah. 0. We're done. Fine. Complete. I'll be hanging out if you guys want to come talk to me about the GitHub AT-AT, Terraform, Azure, microservices architecture, application development, whatever. I like to talk about stuff. I have opinions. So I'll be at the conference. Come up to me. I promise I won't wear my AT-AT helmet anymore. Yeah. All right. Thanks.